Welcome to solverfy.
Okay, so we're going to do chapter 22, problem 41 here, and it says a flat ring with inner radius r0, outer radius 4r0 is uniformly charged. In terms of the total charge q, determine the electric field on the axis at points 0.25 r0, and for part B, 75 r0. Okay. So first we can, using the hint that it gives us, we can treat the source as a superposition of two disks, with one disk being a radius r0 with a charge of with a negative charge, so q less than 0, and then another disk out here with radius 4r0 with a positive charge, such that I'm going to call this q1 and q2, such that q1 plus q2 equals the total charge q. So we can now approximate the electric field at any point as just the sum of these two fields. So if we're talking about in terms of A, when we're at a distance 0.25 r0 from the center, we can approximate both disks as infinite planes because they're both extend much farther away than where we are. But one has a positive charge and the other has a negative charge. So the only way we can so these we're going to add together and be 0. This is kind of tricky to think. So if we're imagining these as infinite planes, they should have the same charge density, right? So we have one. Think of this one as your really big one, right? With a charge density of positive sigma, and here is a negative sigma, such that here, while they're overlapping, it's going to be effectively 0 charge because these counteract each other. And since we can, if we're looking at just 0.25 r0 away, our two effective disks that we're thinking about are overlapping each other, so the charges are exactly canceling each other out, leading us to the 0 electric field. It's kind of confusing to think about, but trying to go through it a couple times if you're confused, because just think about it as two disks. You can also think about it as if you had 2 point charges of positive and negative q on top of each other. If you're anywhere around them, it just looks like there's no charge there because they cancel each other out. Part B wants us to do it when r is 75 r0. So now we're so far away from the ring, we can approximate the field as a point charge. So if we approximate it as a point charge, the electric field is simply 1 over 4 pi epsilon naught times the total charge, which we said was q, over the distance squared. Oops. Simple as that. Awesome.